parameterization. Okay. The simplest parameterization is the following, the simplest. Okay. I need x to be a function, and then y is a function, and then I need an interval. Okay, an interval. Okay. The simplest way is the following. Okay, you take y. طبعا we have to start with the given. We know this. This is given to us. Okay. So the simplest way, you take x here, f of x here, x. Take x to be t. Just take x equals t. Now, if I take x equals t, what is y? What is y?
f of t.
Of t, exactly. So I just take x equals t, so y equals of t. So this is the simplest parameterization. Okay. Take x equals t, then y will be of t. Okay. Now, what is the interval for t? What are the possible values for t? Okay.
This is the same as x.
Y the same as x? Okay.
Because x is equal to t.
Exactly. Okay. So here x equals I, x in I, and x equals t. So just replace x with t. دي حتكون I. The same thing. Okay. The same thing. Okay. This is why it is the simplest, because everything is in front of you. You can get it from the Cartesian equation. Okay. This is the simplest way to parameterize. Okay. This is one. This is the simplest way. Are there other ways? Yes, there are other ways, but it is better to illustrate them through examples. So at least you know one. This is the simplest. Okay. You keep it always in your mind. Variations will be in the examples. In the examples. Okay. So before I go to the example, is it clear now? Is parameterization clear to you? Is this method or the simplest parameterization is clear to you? Okay.
Yeah, it is clear.
اوكي اذا كان ممكن بس واحد منكم احد الطلاب صوته يطلع يمكن يشرب شاي صوت شرب الشاي طالع فممكن يعمل ميوت بس يعني. اوكي يعني كذا الحين اشرب على راحتك ما في مشكله. Okay, so I will illustrate this and other variations through the examples. Okay, example here, example. Okay, find a parameterization. Parameterization. For the line segment. With end for the line segment with endpoints 0, 2, 0, 2 and 1, 0, 1, 0. Okay, solution. Okay, so it is a line segment. I can graph it, just to see how it looks. Okay. This is 2, this is x, and this is y. This is 2 and 0, and this is 1. I have this line segment. So this is the line segment. I need to describe this line segment by parametric equations. I need to parameterize it. Okay. How can we do this? Okay. طبعا, you know one way to parameterize, which is the one given above. Okay, and this one depends on finding a Cartesian equation. If you know the Cartesian equation, you can parameterize. Okay. So for our question here, for our example, I have to find Cartesian equation for the line segment. Okay. Find a Cartesian equation. Find a Cartesian equation for the line segment. How to find a Cartesian equation for the line segment? How?
First, we can.
Yeah. It is يعني just find the equation of the line. That's it. Find the equation of the line. Okay. Find equation of the line. This is how it is. معناته I need to find the slope. Change in y over change in x. Okay. It is 0 minus 2. 1 minus 0, which is h minus 2. So this is the slope. And you have 2 points. You can choose either one. Maybe the simplest is, I will choose the second one here, 1, 0. هتكون ايش؟ equation. هتكون y minus 0 equals slope minus 2, x minus 1. Simplify, you get the following. Y equals minus 2x plus 2. Okay. This is the equation of a line. Okay. Slope and a point. Okay. And this is orientation. Okay. Question now. I have y, the equation y equals minus 2x plus 2. Now, the graph of this equation here, will it be the line segment or a full line?
A full line?
A full line. Okay. If you take y equals minus 2x plus 2, it's just the full line. Okay. But in my question, I need a line segment. So how to get a line segment? Okay.
With restriction.
You have to restrict x. Here, as it is here, it is just a full line. I need a line segment. So x between what and what? Okay.
Between 0 and 1.
0 and 1. Okay. This is 0 to 1 from here to here. Okay. Now it is a line segment. Without the interval, it is a full line. It is not a line segment. With the interval, it is ايش? It is the line segment. Okay. And now this is ايش? The Cartesian equation for the line segment. Now parameterization. One parameterization. The simplest. Well, how you take x equals ايش? t. As we did above. If I take x equals t, what is y? Y will be ايش? Minus 2t plus 2. What is the interval? The same interval, t in 1. Just replace x with t. You get this one. Okay. But this is the simplest. This is ايش? The one we explained above. Okay. You have this, just take x equals t and y equals of t at the same interval. Okay. This is the simplest. This is the minimum. The minimum that you have to know. Make sure it is clear to you. Okay. Before I continue, is it clear to you up to now how to find at least the simplest parameterization?
Doctor, shouldn't x be between 0 and 1, not 0 equal 0 and 1?
You mean the interval included or open?
Yes.
It is included and a line segment from with end point 0 to 1 0. So both are included.
Okay, thank you.
لأن لازم في end point قال لك with end points. Okay, and included.
Yeah, thank you.
Okay, so is the first parameterization clear? Okay, the obvious one. Is it clear to everyone? Okay.
Yes, clear.
Because now we'll give other. Now this is the minimum, but now we can find other parameterization. Other parameterization for the line segment. Okay. Now other parameters. So حد بيسأل?
Yes, I didn't understand the interval from 0 to 1.
Okay. Without this interval, if I remove this one, okay. Let me remove it now. Okay. Okay. What is the graph of y equals minus 2x plus 2?
No, a line, a full line.
A line. A part of a line segment, or a full line. Okay.
لا, full line.
A full line. بالضبط. يعني حتروح إلى it will extend to infinity and minus infinity. But our question, I need have a line segment. So okay. I have to restrict x. I cannot take all x. Okay. X has to be from 0 to
okay.
دكتور.
Yes.
بس سؤال يعني شو الفائدة من البارامترايزيشن؟ يعني ليش بس غيرنا بدل x with t؟ يعني شو what's the benefit of this؟
No. هو Maybe your question, can you just leave it for a while and then ask me? Maybe it will become clear, okay? Leave it for a while. I will find other parameterization, then remind me, ask me the same question, I will answer you, okay?
Okay, thank you.
So this is the simplest way to parameterize. Now, other parameterization, I will give you few, maybe two, and then in fact, you can find infinitely many, okay? So let me take, for example, another parameterization.
So, Doctor, it's not a unique.
No, it is not, okay? There are many, in fact. Another parameterization. So pay attention so that you will learn and really to find many, infinitely many also. Now, another parameterization is the following. Now, I will take this equation here. Instead of working with this, I will take this one now. The original one, okay. And I will take t to be this one. Just this, the parenthesis t. So I will say let t x minus 1 equals t. Okay. In this case, what is x?
T plus 1.
T plus 1.
You take one to the other side, just exactly حتكون t plus 1. Then what is y?
f of t plus 1.
What is y? Okay.
minus 2t.
Minus 2t.
Y minus 0 is y. Minus 2 times t. X minus 1 is t. حتكون minus 2t. Minus 2t. That's it. What is the interval? T between what and what? Okay. Here, طبعا the same interval. And you have x between 0 and 1. This is the line segment.
minus 1 and 0 and 1.
يعني فأنا الآن the same interval x. I need x minus 1. So subtract 1 حتكون minus 1 less than x minus 1 less than 0. And this is t. Minus 1 to 0. Because I let x minus 1 to be t. حتكون minus 1 to 0. This is another parameterization. Okay. A third parameterization. Now here in the first parameterization, I take x equals t. Can I take y equals t or not?
Yes.
Yes.
You can take y equals t. Okay, y equals t. Then in this case, okay, I have how to find x. You solve for x. فهنا t equals minus 2x plus 2. Solve for x حتكون ايش 2x equals 2 minus t. إذا x divided by 2 حتكون 2 minus t over 2. Okay. Let y equals t and solve for x. This is h. Okay. What is the interval for t? What is the interval for t? Okay. This is the line segment. Okay. What is y between what and
0
what?
to
0
0
to
2.
0 to 2.
Yes, from here to here. Okay. 0 to 2. Okay. When you take y equals 2, when you take y equals 3, حيكون t between 0 and 2. Okay. Just play with the original equation. Play with the original equation. Okay. This is ايش 3. Let me say 3 parameterization. I can take, for example, what I can take. I take 2 to the other side. حتكون y minus 2 equals minus 2x. Okay. Then take y minus 2 to be t. This I can take this to be t. Okay. Or I can take this to be t. Okay. Okay. Play with them. Play with the original equation. Okay. And you will get actually infinitely many parameterizations. Okay. Okay. Well, okay.
Doctor,
Yes.
all this parameterization the same.
No, they describe the same line segment. Okay. They all will give me the line segment, the same line segment. Okay.
Oh.
And so parameterization is not unique. Okay. You can find many parameterization for just one single curve. Okay.
Okay, get it. Thank you.
Now, one of you asked me a question. I told him to wait. Okay, now can you repeat your question, or is it clear?
Yes دكتور.
Mhm.
اللي يعني ايش فكرة ان نحول x with t and y with of t. What is this يعني؟
This is a way how to describe a curve by parametric equations. This is one way, possible ways to describe a Cartesian curve by parametric equations.
Okay. Thank you.
Maybe your question is the following: what is the importance of parameterization, or why we study parametric curve? Maybe.
صحيح.
If this is your question, then the answer is different. Okay. What is the importance of parametric equations, or why we study parametric curves or parametric equations? Because in some applications, okay, when you have a curve, sometimes it is better to study the curve with Cartesian equation in x and y. Sometimes it is better and easier to work with parametric equations. Okay. It is a matter of preference. Sometimes it is better. It is easier to work with parametric equations. Sometimes it is better to work with Cartesian equations. But this is another way of describing a curve, so that it becomes easy to work with curves, really. Okay. But this is one answer. Okay.
Okay, thank you.
Okay. Any question about parameterization? Okay. This is the end of this section. This is the end of section 10.1. Now we go to section 10.2, okay, which is a continuation, of course. Okay. 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 Section 10.2, which is calculus with parametric curves. So now we work with parametric curves, and we give some applications, some applied problems. So basically, we study how to compute the slope of a tangent line to a parametric curve. We study concavity, how to find the areas, arc length, and surface area. So these are some applied problems on parametric curves. This is the objective of this section. Okay. I will start with the slopes today. Okay, so let me go to slopes. Okay, so how to compute the slope of a tangent line to a parametric curve. Okay, so you have, for a parametric curve, you have x equals f of t and y equals g of t, in some interval, and I have a curve. X and y, and I have something like this. Okay. Let me say this is ish. Okay. At certain point t0, at certain time, I have the point x0, y0 at this point here, when t equal to 0. Now I have a tangent line to the parametric curve. I need slope, but I just need to compute the slope. Once I computed the slope, you can find the equation of the tangent line. Okay. So how to find the slope? Still, the curve is in the xy plane. You have x-axis, y-axis, a point. The slope, really, the answer is very simple. It is just like Math 101. What is the slope in Math 101? Okay. Derivative. dy, dx. Okay. Just like Math 101. dy, dx. Okay. But pay attention. Okay. Now here the curve here. Okay. If it is described by a Cartesian equation, y equals f of x, okay, then how to find dy dx? It is the derivative, صح ولا لا? It is just f prime of x at x0, at x equals x0. This will give us the slope. Okay. If the curve is described by a Cartesian equation. So this is math 101, math 101. Okay. But in math 201, the curve is not described by a Cartesian equation. Okay. It is described by parametric equations. Okay. So how to find dy dx in this case? Okay. How to find dy dx in this case? So here we assume, طبعا, we make an assumption that y is a function of x. Y is a function of x. And we assume we can do this. Okay. Y, we can write y as a function of x. Okay. Y is a function of x, but here x equals of t, so x is a function of t also. X is a function of t because x equals of t. Now we apply the chain rule of math 101. Chain rule of math 101. Math 101. So find the derivative of y with respect to t. How? What is dy dt? What is dy dt? By the chain rule, you find the derivative of y with respect to x first, dy dx. Then the derivative of x with respect to t times dx dt. This is the chain rule, صح ولا لا? Do you remember it from math 101? Or you forget it?
Yes.
Yes, yes.
تبخرت يا دكتور خلاص.
هذا لا، إذا تبخر لأن عودنا لكم إياه. أوكي. Okay, which is natural, don't worry يعني. But this is إيش a reminder. Okay, يعني to go from 1 to t, I can go first from 1 to x, then from x to t. I go in a chain, in a sequence. Okay. Now I need dy dx. I solve for dy dx. Okay, for dy dx equals dy dt divide by dx dt. طبعا when you divide, you assume dx dt not equal to 0. And this is the formula for dy dx. This is the formula. For parametric equations, how to find dy dx, I have a formula. This is the formula. Okay, dy dt over dx dt. Okay, the formula is not difficult to memorize. If you just notice in it, dy dx equal dy dt over dx dt, as if you are dividing by dt. So هنا dt هنا وهنا dt, as if you are dividing by dt. Okay, صح ولا لا? Okay, so as if you are dividing by dt, dy dt over dx dt. Okay. Okay, so this is how to remember this formula. Okay, so this is the formula. This is the formula for that derivative. Okay, let me give you an example here. Example. You have parametric curve, x equals, let me say, t cube minus 3t, and y equals t squared minus 3. A parametric curve with this parametric equation. The first part, find an equation of the tangent line, to the parametric curve at the point corresponding to t equals 2. And when time equals 2, what is the equation of the tangent line? Okay, this is the standard question in math 101. How to find the equation of a tangent line. Okay, slow. How to find this equation of a tangent line in math 101? Okay.
Find the derivative.
Okay, يعني to get what from the derivative? Okay.
The slope.
The slope.
Okay, so to find the equation of a line, you need two things. You need a slope and what? Okay.
Point.
A point. So for any line, you need a slope and a point. First, start with a point. How to find the point? Okay. You have t time, t equals 2. What is the corresponding point? What is x and what is y?
x2.
You substitute in the parametric equation. Substitute in the parametric equation. When t equals 2 I can find x and I can find y. حتكون substitute حتكون ايش 8 minus 6 which is 2 and y equals 4 minus 3 which is 1. So the point is xy equals 2 and 1. Okay. So this is the point. So just substitute the value of t in the parametric equations you get x and y. Okay. Now for the slope for the slope I have to find dy dx. How to find dy dx? I have a formula star. Okay, this is the formula. Okay, so this is dy dt over dx dt equals what is y? T squared minus 3. Then what is dy dt? It is 2t over dx dt هتكون 3t squared minus 3. Okay. Now what is the slope? Slope equals dy dx at t equals 2. When t equals 2, because I am given t equals 2 here. Okay. Substitute, this is h2t over 3t squared minus 3. When t equals 2, this is 4 over 9. 4 over 9. You have a slope and I have a point here. Equation. تكون y minus 1 equals 4 over 9 x minus 2. Okay. And this becomes, after you simplify, so this gives us the following: y equals 4 over 9x plus 1 over 9. Okay. So this is the equation of the tangent line. Okay. Is it clear to everyone? Okay. This is the first simple example. Okay. The equation of a tangent line. You need a point and the slope, just like Math 101. The point, this is how to find it. The slope, you have a formula for the derivative, and then just compute and then substitute. Okay. Any question?
دكتور هو قال find an equation المفروض يحدد إذا إنه كارتيزيان ولا بارامتريك ولا
هو عادة إذا ما حدد معناته كارتيزيان. أوكي. إذا ما حدد. أوكي. يعني هو عادة يعني they leave it like this. Yes, it is better to specify, but خلاص here it is left as Cartesian. Okay, it is left as Cartesian because if you want it to be parametric, then if you have to find the Cartesian, then you parameterize it. Okay, and just you do parameterization. It will be a longer process. So just they keep it. They want only the Cartesian equation only. Okay. Okay. Now we have just some recall some facts from Math 101 also about the slopes and etc. So this is the formula, our formula. This is our formula for the derivative. Now just let me do some recall some simple point, which is horizontal tangent, horizontal. When do you have horizontal tangent?
When dy over dt equals 0.
Just orient in Math 101. When do you have horizontal tangent? If the derivative is ايش?
Equals 0.
0. The derivative is 0. يعني when dy dx equal to 0. Now here with this formula, dy dx will be 0, 1. Okay.
when dy over dt equals
When
0.
the numerator is 0 and the denominator is not 0. Okay. And if the numerator equal to 0 and the denominator is not equal to 0. Okay. So here we will have horizontal tangent when dy dt equal to 0 and dx dt not equal to 0. Okay. If these two conditions are satisfied, then we'll have horizontal tangent. Okay. When do you have vertical tangent? When do you have vertical tangent?
When the denominator equals 0.
dx over dt 0.
Vertical tangent معناته the slope is undefined صح ولا لا؟ Or we say infinity slope. Okay. فهير this will be undefined if the denominator is 0 but the numerator is not 0. So you have a number over 0. So it becomes undefined, okay, or infinite, okay. So here we have dx dt equal to 0, dx dt equal to 0, and dy dt not equal to 0. Vertical tangent. So with this formula, just pay attention here, with this formula here, at a certain point t, when you substitute t, you might get a number over a number, like the example we gave. So you have just a number, okay. Sometimes you get a 0 over a number, so حتكون 0, horizontal tangent. Sometimes you get a number over 0, which is undefined, so it be vertical tangent, okay. There is a fourth possibility, okay. And when you substitute, you get 0 over 0, okay. So this is a fourth possibility, okay. So f at t0, f at t equals t0, both, okay. dy dt equal to 0 and dx dt equal to 0. Then what is the situation here? Will we have horizontal tangent? Will we have vertical tangent? Or maybe you have none, okay. What do you think, okay?
I think
No graph.
use L'Hopital rule.
0
over 0.
فهير when you substitute a value, you get 0 over 0. فهنا you have to take limits. You take limits. Limit as t approaches t0 of dy dx, because it will be 0 over 0. So use L'Hopital's rule and see what you get. Okay. If you get the limit equal to 0, then horizontal tangent. If the limit is plus or minus infinity, then vertical tangent, okay. If neither, just get a real number, then it will be neither horizontal nor vertical, okay. This is how to deal with the last case. If numerator and denominator are both 0, you have to take limits, apply L'Hopital's rule, and based on your on the value of the limit, you can conclude that is whether it is horizontal, vertical, or neither. Okay. So this is some points from really Math 101. Okay. Let me give you an example. One example here. So I will take the same example here, the same x equals t cubed minus 3t, y equals t squared minus 8. This is part A. Now part B. Find the points on the parametric curve, where the tangent line is horizontal. Solution. Okay. So when you have a curve, I need the points where the tangent is horizontal. Okay. When will the tangent be horizontal? Okay. When will the tangent be horizontal?
And dy over dt equal to 0.
Okay, so horizontal tangent, when we use the formula we wrote above, when dy dt equals to 0 and dx dt not equal to 0. So I need to find the values of t satisfying these. Okay. طبعا هنا x equals يعني the questions t cube minus 3t and y equals t squared minus 3. For now, I have to find dy dt equal to 0. Okay. What is the derivative of y? حتكون 2t equated to 0. This gives me t equal to 0. So there is only one value satisfying the first condition. Okay. Dy dt equal to 0 when t equal to 0. I have to check t equal to 0, does it satisfy the second condition or not? Okay. dx dt. What is dx dt? It is 3 t squared minus 3. Substitute t equal to 0 هتكون h 0 minus 3, which is minus 3, which is different from 0. So it satisfies the second condition. So I have one value, so t equal to 0 satisfies the two conditions, the conditions اللي هما dy dt equal to 0 and dx dt not equal to 0. I have only one value. So at this time, there is only a horizontal, there is one horizontal edge tangent. Okay. What is the corresponding point? The corresponding point is, okay. يعني this is the time. I need the point. The point لازم يكون ايش x y صح ولا لا؟ This is ايش x y.
0 and minus 3.
How to find the point? Okay.
From the original equation?
Yeah, always يعني in the curve, always t, look at it as time and then substitute to get the corresponding point. فwhen t equal to 0 حتكون 0 minus 0 حتكون 0 here. y 0 minus 3 حتكون ايش؟ minus 3. So at this point 0 minus 3 there is a horizontal tangent. واضح ولا لا؟
Yes.
Okay. In the lecture note, you have part C, which is find the points where the tangent line is vertical. You do the same thing, just apply the conditions. They are in the lecture notes. You can. I will inshallah upload them today, and you can check them. Okay. One last observation here. Okay. For part B here, notice what we have in here. You find dy dt equal to 0. Okay. You substitute dx dt, it is not equal to 0. What if when you substitute, when you check dx dt, it becomes 0? What do you do in that case?
Take the limit.
Take the limit. يعني if I substitute, if I check the second condition and it is 0, يعني both are 0 حيكون صح ولا لا؟ فin that case you have to find, you are in the third case. You have to check the limits. Okay. If both at t equal to 0, if both are 0, you have to find the limit. And based on the value of the limit, you decide whether you have vertical or horizontal. Okay. Again, you have an example in the note about this. Okay. So this is for the slope. This is for the slope. Okay. I will leave concavity for next time because I didn't want to do part of it and continue with next one. So it is better to leave it for next time. Okay. Do you have any question? Okay, so just a remark about the office hours. The office hours will be at night. Will be online, of course, and to be at night from 8:30 to 9:15 p.m. Sunday, Monday, Tuesday, and by appointment. I will create a team. I will call it office hours team. If it appeared today, then I will be available tonight on office hours. If it is not available, whenever it is available, just remember this. Okay, remember that time. If it is available tomorrow, I will be available in the office hours also. So if you have any question, you can ask me through the office during the office hours. Okay. This is Ash for the office hours. Try, as I told you last night, try to check web assign. Okay, and you guys go and practice at least the first section. If you have any question or anything, you can always ask. Okay, this is for today's lecture. If you don't have any question, you may leave. Have a nice day. If you have a question, you can ask. Okay.
Thank you, Doctor.
You are welcome.
Thank you.
ثانك يو دكتور.
You are welcome. حياك.
دكتور الكويز اللي على الشابتر هذا اللي مسموح أكثر من محاولة نحل فيها؟
الاثنين، البراكتس كويز والشابتر كويز كلاهما أكثر من محاولة. أوكي. لكن البراكتس كويز ما عليه جريد، ما عليه سكور. الشابتر كويز the score will be the score of the last attempt. اوكي
تمام واضح دكتور. تمام.
أوكي.
الله يعطيك العافية دكتور.
الله يعافيك.